Dear students, in this video presentation, we'll be discussing second ML lab programs, machine learning lab program, which deals with candidate elimination algorithm. In the previous lab session, we saw how to obtain hypothesis from the positive example, that also called find S algorithm. S stands for specific. The, here will be given data set. We need to implement candidate elimination algorithm to output a description of the set of all hypotheses consistent with training examples. Before dealing the lab program, we'll see some of the terminologies like consistency, consistent, and version space. Here, this is the given data set. As you can see, this last column is the possible result. It can be a positive example or it can be negative example. This last column is also called concept. These are all the attributes, all the features, sky. These are all the values for that sky. It can be sunny or it can be rainy. The temperature, air temperature, it can be warm or it can be cold. Humidity, it can be normal or it can be high. Wind, it can be strong, it can be normal, like that. And water content can be cool, can be warm. And forecast can be same or change. These are all the possible values for these attributes. If this is the case, this concept is the result. Enjoy sport. This can be treated for the swimming or playing any game. Okay, play can be started. That is the meaning. So this is the concept. These are all called X. This is concept. C of X for the first one is sunny. For the second one is warm. So it is denoted like C of X. Coming back to what is consistent. A hypothesis H is said to be consistent with the set of training examples D if and only if hypothesis is equal to concept for all the attributes. So that is mathematically represented like this. Consistent, that hypothesis is said to be consistent in that training data set for all x in the concept which belongs to training set, where it is said to be hypothesis and concepts are same. A training example X is said to satisfy hypothesis H when h of x equal to 1, regardless of x, it is a positive or it can be a negative of the target concept. So X is said to be consistent with hypothesis if and only if hypothesis and concepts are same. Now we'll take the example. This is the table and assume that this is a hypothesis. This is a hypothesis. H equal to sunny, warm, anything, strong, anything for these parameters, for these attributes. So the question mark indicates it can take any value. It is not a matter. So the first parameter should be sunny, second should be warm, third can be anything, fourth should be strong, fifth, sixth can be anything. So that is the general hypothesis that is obtained. So these are the four data available data, four rows from the data set D. We'll check whether are consistent or not, whether the concept is consistent or not. The hypothesis H is consistent with the data set. Here, see, the hypothesis says that the first parameter is sunny. In the concept also it is sunny, so it is matching. The second parameter, second value in the hypothesis is warm, second value in the concept is warm, so both are matching. Third parameter can be anything, here normal is there, it is ignored. The next is strong, both are matching. Last two are can be anything. So concept is matched. So this is consistent. In the similar way, you can check the first parameter sunny, warm, ignored, strong, ignored. So this is also matching. Here, the first parameter in the hypothesis is sunny, but in the concept is rainy. So here it failed. So it is not consistent. In the last one, the first parameter sunny, yes, warm, both are matching, can be anything proper, strong, strong matching, last two can be ignored. So this is also matching. So this third is not consistent. Last three are first two and the last one are consistent. For this case, suppose the hypothesis is this one. We'll check whether all these are true or not. First parameter can be anything. Sunny, sunny, rainy, rainy. Everything is not true. All these are matching. All these are consistent if first parameter in the hypothesis is anything or that question mark. Version space. The version space, it can be denoted like VSHD with respect to hypothesis space H and training example D. H is the hypothesis, D is the training example. So which is a subset of hypothesis. Subset of hypothesis. Now we'll take the small example. Let H be the hypothesis, H2 is the other one hypothesis. Okay. Now which is a subset? See, H and H2 is a version space because all these values are here in H2. Can be anything, but here question mark is there. So both, it is a subset. H is a subset of H2. In this case, for this example, you can trace whether H1 and H2 are the part of that H1 and H2, and the specific is H6 will take H1 and H2 are subset or not. Sunny, yes, sunny, can be anything, it is true. Second parameter is warm, second parameter is warm, none. Okay, in this way you can check our version space or not. We'll see that with example later. Here in this candidate elimination algorithm, we need to have two different sets. One is the general boundary G, other one is the specific boundary S. General boundary G with respect to hypothesis space H and training data D is a set of maximally general members. Maximally general members. But in case of specific boundary, it is minimally general member or maximally specific. Maximally specific, that set is yes. Maximally general, that set is denoted as G. So this is the training example that you are going to consider. In case of find S algorithm, we have considered only the positive example. Here we have to consider both positive example as well as the negative example. Here we will be getting two different sets. One is the general set, other one is the specific set. We'll start seeing the working of candidate elimination algorithm. In the training examples, there are four data sets for the parameters sky air temperature, humidity wind, and water forecast. Positive examples, there are three and only one negative example. So here, compared to the find S algorithm, here we are going to consider both positive as well as negative example. So here we will be getting specific hypothesis as well as the general hypothesis. In case of find S algorithm, we got only specific hypothesis. Here we will be getting both general as well as the specific. For all positive samples, we have to move from specific to the general. In case of negative example, you have to move from general to specific. These 2 points you have to remember. We have to initialize both hypotheses with a specific with general. Pi or 0 can be used for specific hypothesis. For the general, question mark is used. This is the initial stage of this algorithm, initializing S and G. We'll take one by one example. Now we have to see the last column, which is the concept. The last column here, it is the positive example. Okay. Now in this case, the specific hypothesis set to or initialized to 0, 0, 0, 0, 0, 0, and general hypothesis initialized to question mark, question mark, question mark, question mark, and question mark, question mark. The example is positive. Example is positive, and these are the values that are there in that first example: sunny, warm, normal, strong, warm, same. Then, as in the initial relation case, no, yes, was values were 0, 0, 0. That has to be replaced by this parameter. So no change in general. This general hypothesis is no change, no modification is done for positive example. The second example is positive, sunny, warm, high, strong, warm, same. You have to compare now the hypothesis with this concept. Sunny, sunny are matching capacities. Warm, warm are matching capacities. The concept is high. Sorry, that training example attribute is high, and the specific that value is question. Earlier it was normal, it changed to high, so it has to be replaced by question mark. This step is almost similar to Finder's algorithm. There is a change from normal to high. There is a change from normal to high, so there is a change, so you have to replace it by question mark. Strong to strong, still strong only. Warm, again warm, warm only, same, no change, so all other parameters are same. No need to modify general hypothesis. So we have considered two examples. The third one is the negative example. In case of Fidesz algorithm, we have ignored this case, but here you have to consider this is the values that are there in those attributes. No change in specific hypothesis. Now, the general hypothesis has got question mark. At a time now, we have to consider only one attribute. So we have to see, is any change in the attribute or not. Sunny changed from sunny of specific change to rainy. So you have to write specific hypothesis value. Sunny change to rainy. This sunny you have to enter. So this is the first set. In the next one for the next attribute, if there is a change from the specific warm change to cold, there is a change in parameter, change in value. So that specific value you have to write it here. Specific value to write, not from the data set. Second parameter is over. Next, as there is a question mark here, no need to consider, you can skip that. You can put all question mark or you can skip. Then strong, strong, no change, you can put question mark or you can ignore, no need to write that question mark is. Then in the next fourth parameter, warm change, warm remains same, no need to have that entries, you can ignore. Same change to change, same is change to same, so here you have to make one entry. So three parameters changed. Sky parameters change from sunny to rainy. Then air temperature is also changed from warm to cold, to make entry here. Forecast is changed from same to change. So three entries you have to make in general hypothesis. So now you consider three. Last one, that is the positive example. Both positive as well as the negative you have to consider. Now the example is positive example. You have to change the specific. No change in sky. Earlier it was sunny. now also same. Air temperature, earlier it was warm, now also same. Next, humidity, because earlier it was question mark, no need to consider that parameter. Strong, that also no change. Warm is now changed to cool, so there is a change in parameter. You have to substitute it by question mark, you have to substitute this by question mark. Then same is changed to change, same is changed to change, so it is again question mark. So this is the entries to be made or updated in the specific hypothesis. Next, accordingly, you have to modify general hypothesis also, because see, the parameter sun is available here, so you have to retain it. Warm is also available here, so retain it. So anyway, there is no entry for the strong. This one, the earlier case, general hypothesis same, which is not there in the specific. You have to remove, or you have to replace it by question mark. At the end, we'll be having the updated general hypothesis. As there is no more entry here, so it is the end of the process. We have trained one specific hypothesis. It is again same as that of find, and this is the general. The general. We'll take one more example. This is a trace of that program in the diagrammatical form. See, this is the final stage. This is a specific hypothesis for that example, and this is the general hypothesis. This is called version space. This is the subset of this one. Sunny, it is there here. Strong, question mark is there. Question mark takes anything. Sunny, it is here. Warm, it is here. Warm, it is here. Strong takes question mark. Takes question mark. So this is a subset. So this is version space of this one. This is a specific one. So sunny, warm, question mark, strong, question mark, question mark. If this is the case, the concept will be yes. This is how the machine learns from the concept. Now we'll take one more example. Having three parameters, size, color and shape, the class is having one of the value, like positive example or negative example, yes or no. The first is to initialize. Most specific boundary is initialized to all zeros. Number of zero depends on the number of parameters. Here there are three parameters, so three zeros. Most generic boundary should be initialized with question mark. The first example is positive example. First is positive example. So earlier it was 5 or 0. So you replace it by the data. Small, red and circle. No change for general hypothesis. We have completed the first data. We'll go for the second one. Second one is the negative example. So this is yes earlier value. There is a change from specific value small to big, change in value from red to blue, and no change for circle. Wherever there is a change, for that question mark has to be replaced by the specific value. Like here in the general, you have to replace that question mark by the specific value small, one question mark at a time. So first set for this parameter, second set for this parameter, no change. So no need of writing all question mark, you can keep, but later we are not going to consider it, so better not to write. So we have completed the second one. Go for the third one. Third one is a positive example. Example is positive. Then the values are small, blue and circle. Small, blue and circle. Small from the specific earlier small. Now also there is no change, so keep as it is. Earlier specific value was red, now it is blue. Red is changed to blue, so replace it by question mark. There is no certain consistency, so whenever there is no consistency, inconsistent, replace it by question mark. Then there is no change from circle to circle, so keep as it is. Keep as it is. After this, you have to see whether anything to be modified for general, because red is not there, so you have to remove. Small is there, okay. Red is not there, you have to remove it. So this is the updated general hypothesis. We have completed the third one. Go for the fourth one. Fourth one is negative example. So the specific is same, small, question mark, circle. And in case of general, whichever is not there, that you have to remove, because small keep as it is. See here, small. Small takes two possibilities. You don't take the unseen value, the seen values. The small takes blue, small takes red. So there is a inconsistency. Small in size takes two different possible values for the color, that is blue and red. Both you have to make entry. Small, red, and as it is question mark. Small, blue, question mark. Then the circle can take any value. Circle can take any value. Small red is there, small blue is there. So you can put that by question mark, or you can keep as it is. See here. In this case, small red is not there, so you have to remove. Small blue is also not there, you have to remove. So these are all the two inconsistent value that has to be removed. Then the fifth example is again negative example. Fifth is negative example, which uh, this the specific is same. Specific is same, and there is change in the question mark again same. The second parameter is also same, and as we are not modifying the specific because it is a negative example here, again there is no change. So this is the final answer on the specific hypothesis and general hypothesis. You can try this one. First start with the null, positive example, negative example, positive example, like that you try and check the answer from the program. Pause and trace the solution. The first example is the positive example. Earlier it was null, so you replace it by this one. Rest of the things are null. See, in this example I gave all the question mark, so you can ignore it or you can put required number of question mark for all the parameters. So this is the specific hypothesis after the first example. Second example is no need to modify specific. Here there is a change. Earlier it was Japan, now also Japan, so no need to modify. Earlier it was Honda, now it is Toyota. So write Honda here, one parameter at a time. Blue change to green, modified. 1980 modified to 1970, write it. Economy change to sports, write it. So these are all the hypotheses for general. This is the specific one. The third example, this is a positive example. Now the old value was Japan Honda Blue 1980 economy. Japan Honda Blue 1980 economy. Compare the value. Japan same, retain it. Honda change to Toyota, replace by question mark. Blue remains same. 1980 change to 1990 question mark. Economy. This is yes value. This is yes. Then the first one there is no change, retain it. Second one's here, Honda change to, or you can say uh, there is a difference value, so you replace it by question mark. Blue as it is, question mark as it is, economic as it is. So blue is not there, so you have to remove this one. Sorry, this one you have to remove. Blue you have to retain, economy you have to retain, Japan same, you can ignore it. So like this, you trace this example, come to know. Once you trace one or two questions, come to know, you'll understand candidate elimination algorithm in a better way. Okay. Here, this is my data set, import CSV with open the path of the file with the extension .csv as f. CSV.reader of f. Keep that in object CSV file. Dump the data to data using list. Print the data. Print the data except the first one, except the label. Dump all the data to yes. Okay, that means we are not initializing with the five value. We're directly copying the first one to here. Then G, general hypothesis. Put question mark. How many question mark? That range of yes. That many number of questions. If there are five attributes, so you should have five question mark in G. Five question mark in G. It depends on number of parameters. Now, for the data set, see the last value. If it is positive, you have to change that to positive. If it is true, you have to change it to true, like that. The last value you have to change. In my example, I gave yes and no and case sensitive. I gave lower cases, it should be the same way. If the last is positive example, if the last column is positive, then what to do? Compare general and specific. Compare general and concept and specific. If there is a difference, replace it by question mark. Also, you have to put question mark in the general. If it is no, what to do? Negative example. For all the parameters, if I and j are not equal, say, if not equal, you replace yes in g. This is the thing. If they are equal, replace by question mark. Okay, if the parameters are not same, copy s to g. If parameters are not same, if the values for those parameters are not same, specific and the data value are not same, copy specific to general, otherwise copy question mark. So you have to repeat for all the things. Print yes and g each time if you want, it is optional to you. Then I don't want the hypothesis which is having all the question mark. Okay, I have to remove that one. I have to reshape that one. So this is my new list. I have to iterate in G. If there is a question mark, if there is no question mark, for example, if this is say red, if it is not question mark, then only you have to append that to GH, that new list. The complete thing you have to append it, all these question, all this will come. Okay, if that set has got at least one non question mark value, copy whole thing to gh, like that you repeat it for all the things. If all these are question mark, then it won't be appended to gh. So my final answer will be in yes and gh is my fine tuned general hypothesis. So this is how the second program works, that is candidate elimination algorithm, its implementation and working. Thank you.